This paper presents a novel event-triggered fixed-time sliding mode control method for the position tracking and stabilization of an uncertain faulted flexible link manipulator with actuator saturation. The system is subject to unknown uncertainties, external disturbances, and faults. Two kinds of event-triggered extended state observers are developed. The first one to estimate disturbances and uncertainties, second to estimate disturbances, uncertainties, and faults. Subsequently, two event-triggered mechanisms are introduced to reduce the communication frequency in the control loop. To address input saturation, a fixed-time sliding mode control law is proposed, incorporating a newly designed auxiliary function. The main merits of the proposed methodology include its robustness to disturbances, effective disturbance rejection, a reduced burden of communication between the actuator and controller, and faster convergence. The proposed event-triggered strategy ensures that both the control update and the reachability of the sliding surface are guaranteed simultaneously. Furthermore, the Zeno behavior is proven to be excluded for both triggering mechanisms. Finally, the proposed approach effectiveness is demonstrated through baseline real-time Speedgoat machine performed on a two-link flexible manipulator.